shared. So good morning all of you. Welcome back once again to the subject Water Resources Engineering 2. We are in Unit 3, Earth Dams and Spillways. We have spent enough time on earth dams. Now we are taking up the spillways. Last class also we have seen the types of spillways, followed by the design principles of OGE spillway, how the OGE profile is prepared, and what is WES profile designed by the US Army Corps of Engineers. Okay, that we have seen. So depending upon the type of the structure constructed for disposing the surplus water from the reservoir, the spillways are classified. We have seen straight drop spillway in the last class, followed by OGE spillway or overflow spillway. So today we try to look at some other types of spillways like chute or open channel or trough spillway, side channel spillway, shaft spillway, and siphon spillway. How they work and what are the functionalities of different types of spillways also we will see in today's class. Chute or trough spillway. This is the simplest type of spillway, easily provided independently at the low cost. It is lighter and adaptable to any type of foundation. This is the greatest advantage with this chute or trough spillway, unlike the OGE profile. It is easily provided on the earth and rock fill dams also, and the various parts that are there for a trough spillway are entrance channel, control structure, chute channel, and energy dissipation arrangement, which is provided at the bottom. Entrance channel is the approach channel, which is trapezoidal in shape. Side slopes may be 1:1, and this is constructed so as to lead the reservoir water up to the control structure. From the reservoir to the control structure, this entrance channel will be taking care. So from the inlet, in the figure you can see, from the inlet, the water enters, and this is a steep sloped channel leading to the outlet here, maybe the downstream portion of the river. So a OGE curve may be there, and this is a steep sloped channel carrying the water. So the flow through this necessarily will be a supercritical flow because you have a steep sloped channel here. So in this sketch also you may note that there will be certain sidewalls which are provided. So this is one sidewall. This is also a sidewall which guides the water through this steep sloped channel to the river downstream. So this is the reservoir, and the excess water from the reservoir will be disposed to the downstream portion of the reservoir through this channel. So this is a chute or a trough which is having a steep slope, steeply sloping chute or trough, and a sidewall is constructed on both the sides. So this picture provides you the complete description of the trough that is provided and the side walls which are provided here, and through this trough the water flows from upstream to the downstream portion. Chute spillways carry supercritical flow, as we have been discussing about that, because you have a steep sloped channel carrying the water from upstream to the downstream portion. Through the steep slope of an open channel, in order to avoid a hydraulic jump, the slope of the spillway must be steep enough for the flow to remain supercritical. Proper spillways help with flood control, prevent erosion at the ends of the terraces, outlets, and waterways, and are very simple to construct. However, they can only be constructed at the sites with natural drainage and moderate temperature variation, and have a shorter life expectancy than the other types of spillways. The chute, we have seen about the chute or a trough spillway. Now, side channel spillway. The side channel spillway differs from the chute spillway in the direction of flow of water after leaving the crest. What happens in the case of a side channel spillway? What happens in the case of a chute spillway with respect to the direction of flow of water? In the case of a chute spillway, the water flows at the right angles to the weir crest after spilling over it, whereas in the case of a side channel spillway, the flow runs parallel to the crest. So this type of spillway is provided in the narrow valleys where no side flanks of sufficient width to accommodate a chute spillway are available. If those things are not available, the side flanks are not sufficient width, having not sufficient width, then we go for the side channel spillway. So only the difference is that in the case of a chute spillway, water flows at right angles to the weir crest. You know, the crest of the weir may be along the length of the dam, So right angles to that, the water flows in the case of a chute spillway, whereas in the case of a side channel spillway, the water flows runs parallel to the crest. Immediately after falling the crest, the water will be collected in a channel. This channel will be alongside. So see, this is the crest. In the figure you can see all this is the reservoir, and you have the crest of the spillway. So from this crest of the spillway, the water flows here. The water flows here, gets collected. Instead of flowing normal or perpendicular to the crest, it flows parallel to the crest in this direction. Parallel to the crest in this direction. So when the dam is not rigid and it is not undesirable to pass the floodwater over the dam, naturally this type of spillway will be preferred. After crossing over the crest, over the spillway crest, water flows parallel to the crest. So this is how the flow of water through a side channel along the crest, it flows parallel. Next category is the shaft spillway. In a shaft spillway, the water from the reservoir enters into a vertical shaft, which conveys this water into a horizontal tunnel, which finally discharges into the river downstream side. The very purpose of any of the spillways to dispose the excess water. So from the upstream to the downstream portion, it should be disposed, but of course within a course, it should be safely disposed. It should not create any problem to the main structure of the dam or to the reservoir or at the downstream portion. So in a shaft spillway, the water from the reservoir enters into a shaft. A vertical shaft may be provided at some location in the reservoir, and this vertical shaft collects the excess water and it will be directly conveyed to the final downstream portion. Sometimes the vertical shaft may be excavated through some natural rocky island also existing in the upstream of the river near the dam. Vertical artificial shafts may also be constructed sometimes. So look at this figure, how a shaft spillway works. So you have the reservoir with a control weir which is provided here. So water may not be required more than this level. So this is a shaft. This is a vertical shaft. A small funnel type of thing is provided here at the top of the shaft. So the water gets collected over and above this level. The water gets collected, flows through this vertical shaft, conveyed to a horizontal tunnel, and this horizontal tunnel finally lets this excess water to the downstream portion of the river. So this is how the function of a shaft spillway. So the top of the shaft spillway, there will be a vertical shaft, and the top of this vertical shaft is provided with a funnel, and from the control weir, the excess water from the reservoir enters here, gets collected, conveyed through a horizontal tunnel. Finally, it will be let off into the downstream portion of the river. So you can see here a standard crest and a flat crest types are provided here. You may see the purpose of any of these is to see that the excess water over and above this apparel gets entered into this tunnel, into this shaft, and finally conveyed to the tunnel. So you may have a spillway tunnel which is provided, and in this figure you may see this is the top level crest of the dam. So the funnel here is provided slightly below this, because up to this level, when the water is reaching this level, no, the excess water definitely gets entered into this shaft. Finally, it goes through this tunnel and reaches to the outlet or the downstream portion of the river, downstream portion of the dam. You can see here how a funnel type of thing is provided in the figure. In this case, what happened? The water is below this level, so no water is entering here. No water is entering here. So water is below the crest level. So water is to be stored there, the purpose of reservoir. But here you can see excess water is there. The moment the water level is increasing, it is flowing into this and getting collected in this funnel, finally disposed to the downstream portion. A small video showing how this shaft spillway works. Please go through this. So this is how a shaft spillway disposing the water, getting collected over and above the funnel, getting collected into a vertical shaft, finally moving towards the downstream portion. Now we see about the siphon spillway. So siphon spillway utilizes the siphonic action to discharge the surplus water. It consists of a closed conduit system formed in the shape of an inverted U. So the level of the air vent may be kept at the normal pool level, while the entry point of the siphon pipe may be kept still lower so as to prevent the entry of debris into the siphon. Whenever a siphonic action is used, this care necessarily to be taken so that only water enters, debris should not enter into the siphon pipe. So siphons are of two types basically, saddle siphon type and a volute siphon type. And the saddle siphon types are once again subdivided into hooded type and tilted outlet type. A small deprimer hood is kept above the main hood and both the hoods are connected through the air vent. The inlet of the deprimer hood is kept just at the reservoir level. So if I say siphon spillway, basically through a siphonic action, so a spillway here and you have a siphon pipe which is provided. The crest of the spillway, this is a crest of the spillway and this is a siphon pipe which is provided here. So this siphon pipe carries the water, draws the water from the reservoir through the siphonic action, allows to flow through this and reaches to the tail race. Reaches to the tail race or tailwater or downstream side of the dam. So this is how a siphon is provided. You can see here how the siphon would be, how the siphon and its connection would be. So this is a siphon provided here for a dam. So this is called the siphon spillway. The water is only up to this level. You may note that the water is only up to this level, but still because of the siphonic action, the water enters here and moves through the top part body of the dam and finally reaches to the downstream portion without causing any disturbance to the main dam portion. So this is how a canal siphon here is provided here and the siphonic action. I can see how the siphon spillway works. So depriming is the reverse process of priming and it is the action of the siphon from the time air starts entering the siphon through the vents until the siphonic action is stopped. Without the air vent, siphonic action continues till the reservoir level is brought down to the level at the inlet, which is much below the full reservoir level. Usually we try to keep the water level up to F or L. It is a saddle type of siphon in which the vertical shaft has a tilted outlet which maintains the water level in the tilted outlet. So the maximum negative pressure occurs at the crown or the throat of the siphon. To avoid any cavitation, this negative pressure should not exceed 7.5, 7.6 meters of water. The vertical distance from the crown of the siphon to the discharge end should not exceed the value of about 7.5 meters. So this is how air vent is provided and the normal pool level of the water. Through this siphonic action, the water enters and it is drawn to the downstream portion. The discharge through this siphon or the siphon spillway can be taken to be Q is equal to C into A into square root of 2GH. A is the cross-sectional area at the crown, L into B, and L is the length, B is the height of the throat. H is the operating head. So the reservoir level minus center of the outlet if the siphon is discharging freely, or reservoir level minus downstream of tailwater level if the outlet is submerged. C is the quotient of discharge, which will be taken around 0.65. Okay, volute siphon is the other type. Is a special type of spillway designed for the Indian conditions. It consists of a dome supported on pillars with the funnel placed underneath. A vertical pipe is taken down the funnel to pass the discharge through the dam. It is bent at the discharge end. The top or lip of the funnel is kept at reservoir level and a number of volutes are fixed in the funnel to induce a spiral motion to the water passing along them. So this is how a volute siphon works. A volute siphon collecting the water into the funnel and conveying to a horizontal tunnel. The discharge through this volute siphon is given by Q is equal to CA root 2GH only, but this H would be equal to H minus HL. HL is the loss of air through the siphon. Let us look at a small problem. A saddle siphon has the following data. Full reservoir level 135 meters. Level of center of the siphon outlet is 129.6 meters. And HFL high flood level is 135.85 meters. So the freeboard is from FRL to HFL about 135.85 minus 135.85 centimeters. So the dimension, the maximum flood discharge is 1200 meters per second. The dimensions of the throat of the siphon are width 8 meters and height 4 meters. Determine the number of siphons required to pass the flood safely. The siphon discharges freely into the air and assume the quotient C would be equal to about 0.65. So operating head H would be equal to HFL minus RL of the outlet structure is given to be 129.6. So 135.85 minus 129.6, which is 6.25 meters is the total operating head. Assuming C 0.65 and area it is given to be 8 meters width to 4 meters depth. So 8 multiplied by 4. So the discharge through each siphon will be CA root 2GH 0.65 into A32 into root of 2GH 6.25 meters. So 231 cubics of water can be carried by each siphon. But what is the total discharge? The number of siphons required will be total discharge divided by discharge passing through each siphon. So 1200 divided by 231. About 6 siphons are required to be provided. Another problem, a siphon spillway whose cross section is 2 meters high and width 4 meters is provided on the dam. The tailwater at the design flow is 7 meters below the summit of the siphon, and the water level on the upstream side is 2 meters above the summit. Calculate the siphon discharge. What length of an Ogi spillway is required to pass the same flood with the same head water elevation? Assume the quotient for Siphon Spillway is 0.6 and Ogi Spillway it is 2.25. You have a Siphon Spillway, so the operative head would be 7 meters below the summit. So the tailwater design flow is 7 meters below the summit. 2 meters above summit, 2 meters is there, 7 plus 2, 9 meters. And Q will be equal to CA root 2GH 0.6 multiplied by A is 4 into root of 0.4 into 4 into 2 into root 2GH, H is 9 meters. So you have 63 cubics of the discharge flowing through the Siphon Spillway. Suppose if Ogi Spillway is provided, so Ogi Spillway, the Ogi Spillway head will be over and above the crest. It's only 2 meters. So Q is equal to CLH to the power 3 by 2. C is 2.25 and H is 2 meters. So substituting here, now the length L would be equal to 63.5 divided by 2.25 into 2 into root 2, about 10 meters is the length which is required to be provided, So this is another problem. So we have seen basically about 4 or 5 types of spillways, starting from a straight drop spillway, then Ogi spillway, chute or side channel chute spillway, trough spillway, or a side channel spillway, and then the siphon spillway we have seen. Chute, shaft, and side channel and siphon spillways are adapted when there is no adequate space to provide an Ogi spillway. Chute spillway is provided on the earth and rock fill dams. In side channel spillway, the water flows parallel to the crest. It is provided in narrow valleys where side flanks of sufficient width are not available to accommodate the chute spillway. Shaft spillway is used if the topography prevents the use of a chute or a side channel spillway. Siphon spillway may be saddle type or a volute type. It discharges the water with a greater head by the siphonic action. I would like to provide you a video which gives you the overall